oxidation-reduction reactions. The next two types of reactions are oxidation-reduction reactions. Oxidation is the loss of electrons. Reduction is the gain of electrons. These reactions involve the transfer of electrons from one species to another. When one species loses electrons, another species gains electrons. So, when one substance is oxidized, another substance is reduced. One cannot occur without the other. So these types of reactions are often called redox reactions. How do we know if a redox reaction has occurred? We can determine whether oxidation or reduction has occurred by checking to see if the oxidation number of the element has changed. To begin with, we assign an oxidation number to each element in a neutral compound or charged entity. The basis for this system is the assumption, which is not true, that electrons are always completely transferred from one atom to another. The electrons in a bond are assigned to the more electronegative element. The following slides give the rules for assigning oxidation numbers. Rule number 1. Elements in their elemental form have an oxidation number of 0. If we have a neutral element, like helium, He, or hydrogen, H2, or sulfur, S8, then the oxidation number of the atoms is 0, because there is no charge and the atoms are identical. Rule 2. The oxidation number of a monatomic ion is the same as its charge. If we have a monatomic ion, that is a single atom ion, like Fe3+ or S2-, then it really has lost or gained electrons. Rule number 3. Nonmetals tend to have negative oxidation numbers, although some are positive in certain compounds or ions. In Rule 3, we begin to get the rules that help us determine the oxidation numbers of elements where things are not obvious. Remember this rule completely. In compounds, oxygen nearly always has an oxidation number of -2, except for the peroxide ion, O2, 2-, which is worth remembering. Hydrogen has an oxidation number of +1 when bonded to other nonmetals, and -1 when bonded to metals. Because fluorine is the most electronegative element, its oxidation number is always -1, even when bonded to oxygen. The other halogens are often -1, though they can have positive oxidation numbers. Rule 4, the sum of the oxidation numbers in a neutral compound is 0, and Rule 5, the sum of the oxidation numbers in a polyatomic ion is the charge on the ion, could be combined into a single statement that the sum of all the oxidation numbers of all atoms in a species must add up to the charge of the species. Rule 6, treat all atoms of an element in a particular compound as having the same oxidation number. Rule 6 is designed to make life easier for us. All the atoms of an element in a particular compound have the same oxidation number, even if that means it has a fractional value. Let's do an example of how to determine the oxidation numbers of the atoms in the compound K2Cr2O7. Is the compound ionic or molecular? Since it contains metals and nonmetals, the compound is ionic. What are the ions? The ions are K plus and Cr2O7 2 minus, two ions you should know. From rule number 2, the oxidation number of potassium is +1. For the dichromate ion, we know from rule 3 that oxygen will have an oxidation number of -2. From rule 6, we know that the two chromium atoms have the same oxidation number. So, according to rule 5, 2 chromium atoms plus 7 oxygen atoms with oxidation number -2 equals a charge of -2. So 2 chromium atoms equals +12, and each chromium atom has an oxidation number of +6. Remember that a change in the oxidation number of an atom during a reaction means that a redox reaction has occurred. One important and simple type of redox reaction is the single replacement reaction, in which a neutral element replaces an element in a compound. Typically, metal ions oxidize an elemental metal. The metal ions are reduced. Nonmetal ions will reduce the elemental nonmetal. This happens mostly with the halogens, where the element higher in the periodic table will replace the halide ion lower down in the table. These reactions will occur in only one direction. In this example, elemental copper will replace silver ion, but elemental silver will not replace copper ion. This slide gives a list in order for these replacements, called the activity series. An element on the left side higher up in the table will replace something on the right side lower down in the table. A table like this is available on Moodle.